Thank you so much for meeting me for a beer. Cheers.
It's great to be here. Cheers.
Excited to talk to you. Okay, so I want to get into the exciting stuff first. Who has your attention right now? Like, who is the most groundbreaking company out there that just is exciting you?
That's a great question. I think, to kind of rewind back when we founded the company just a few years ago now, it's, there are a lot of companies doing amazing things, but I think what's going on is pretty special and exciting. Yep. And that what is very much aligned to why we founded the company and what we're seeing here now. I will say, it's exceeded our expectations. Even the number of who's that are doing exciting and groundbreaking things has exceeded our expectations. And I think particularly, I'm very excited about some of these companies that are advancing nuclear technology. Yep. And particularly the packaging. Yeah. And the delivery in these kind of micronuclear reactor formats. Okay. So those are some pretty exciting, groundbreaking things that are happening, I think.
Tell me about, So what do you mean the packaging, the delivery? Like, how is it going to change things?
Yeah. I think like one thing I'm particularly excited about is like nuclear in particular is obviously a very promising technology, but the history of it is very much a large construction project. Yeah. And construction is hard and has only gotten harder recently. Yeah. Nevertheless, the energy source is something that we all know is clean. And interestingly scalable. If we only had enough nuclear reactors globally, we'd be able to power our entire civilization. Right. So by taking a look at the advances in the manufacturability and kind of the logistics aspects of things, and taking a nuclear reactor into a smaller form factor that can be drop shipped onto a container, for example. Interesting. I think that's just like novel thinking of like, okay, what is the standardization of containers, and what are the advancements in manufacturing technology for smaller form factors for things like heat exchangers that are critical in nuclear reactors. Basically changes everything from a very large construction project with very large equipment, very large machines, into something that's much smaller, something that wasn't possible 30, 40 years ago. Right. But it's possible now.
And manufacturing was a barrier. Their ability to manufacture these parts and pieces was a barrier before, but now it's been unlocked somehow?
Yeah, that's right. That's right. And I think this is the case not just in nuclear, but in many industries that have historically been construction focused. So take housing, for example. Right. This is another exciting area where, of course, housing has historically, and still very much to this day, is very much a construction project. Right. However, housing is a critical concern for us in society. Everyone. Absolutely. Yeah. And, I think it's like the advances, but also the adoption of using manufacturing technologies to do things like prefabrication. Yep. And using things like additive manufacturing as part of that prefabrication. Right. I think additive is an advancement in technology, but prefabrication is just an adoption of, the advancement in the thinking around what is a system, right? Mm-hmm. So we can prefab this house, for example. Yep. And then using advancements in logistics, get that supply chain moving to the construction site and put up a house in the course of a few weeks, as opposed to many, many months. Right. That changes the entire math of what it means to, and how expensive it is to build a house, for example. And solve the housing crisis. Exactly. Yeah. Right. So we can hope. I'm excited about that. But these are the things where it's like, in certain areas that historically have not considered manufacturing as a critical input, they're adopting manufacturing principles or even manufacturing entirely, right? And disrupting industries that are really hard to move. Very cool. Yeah. If you could help solve one thing, right? Like you've mentioned housing, we've mentioned energy. I mean, if you could say, okay, we're going to use our software, our skills, our expertise. Yeah. To unlock one solution with better manufacturing, what would it be if you just had to pick one baby? One baby. Well, look, I think that's super tough. I think the answer to that would be energy. If we could have like one driver toward an outcome, net outcome, and even energy, it's hard to say that that's an outcome. Like, obviously with the concerns around the climate issue, et cetera, energy has now come out to be like a topic and an industry of its own. So I would drive that one. That's for sure. the more nuanced answer here is we want to be boring. We want to be the infrastructure and picks and shovels under the hood.
Right.
And be so outside of the spotlight and allow these builders to use these abstractions in advancements in our own kind of realm, the digital technologies, right? Advancements in storing large amounts of data,
right?
Advancements in making proactive decisions based on a number of data and having APIs to move that information in and out, and let the builders innovate, right? And innovate on applications for space exploration, innovate on applications for energy extraction, energy storage, housing, etc.
Right.
We want to be that abstracted, that boring, so that we can allow for any of those outcomes and all of those outcomes truly to be realized.
So let me ask a big, hairy question. So if we are relying on the technology to make decisions, to tell us what to do, right? What does that unlock for manufacturers? Like those brains and those minds and engineers, that were focused on that before.
Yeah.
What do they do?
Oh my gosh, it's such a good question. We were just talking about this earlier with our data team, just today, in fact. And one of the thoughts that came to mind is that there are a number of professions that we've had historically.
Yeah.
Things like computer was a profession before it was a device.
Yes.
Is a really interesting one. Same thing with calculator.
Yeah.
These were all professions before they were devices or tools.
Right.
In manufacturing, there are many areas where that is still very much the case. There are professions such as buyer or planner,
right,
or drafter. Drafter is a little bit more old school, where and maybe a good example here, a drafter was a job, but now that computer aided design is their CAD, that has become more automated. So I think drafting is one of the early innings of this. What's going to happen next? Some of these professions that are kind of on like an autopilot loop, or require a lot of rote, repetitive labor.
Right.
In the knowledge space, definitely also in the hard space, allows for people to actually contribute to all the innovations or advancements in quality and efficiency that we need.
Okay.
I think in these various applications, like for example, airplanes are extremely expensive.
Right.
And as we've seen with some of the recent events, can actually have a quality gap that could lead to a lot of problems.
Of course.
We could redirect some of that brain power to help solve those problems,
right,
rather than doing the rote, repetitive work of configuration management or planning or buying, something that you could rely on more from automated decision making.
So we could think about it a little bit like the drafters of the past, CAD, unlocking that and letting them all become architects, letting them all become creative and think about, okay, well, what could a building be? How could it be more, efficient, eco-friendly, all of this stuff. And that brain power is unlocked because they don't have to sit there and draft everything by hand anymore.
Yes, that's exactly right.
So that's a great, that's a great way for all of us to understand that might not be in manufacturing, right?
Absolutely.
Yeah.
Absolutely. Oh, yes. Manufacturing is, the outcomes of manufacturing from, if we look at like the last century, ever since the Industrial Revolution, are pretty grand. I mean, we have these like flying metal tubes in the sky that take us across the world. I mean, this in hours, and it's quite magical. It's quite amazing. However, just the sheer amount of brute force and manual work that have gone into those advancements is non-trivial. And this is why we only have, for example, 2 major airline manufacturers in the world, right? It's a large operation.
Yeah.
But that can change. We can have more. Mm-hmm. We can have more innovation and competition through some of these principles of abstracting the work so that we could focus on the outcome and variability. And we could just apply more effort to, for example, not just having a metal tube flying through the sky, but like blended wing aircraft, which people have been thinking about for quite some time, or things that haven't even been imagined because people are busy doing this manual, repetitive, albeit
stuff. Yeah.
Exactly, albeit knowledge work.
Right.
But like not creative work. Right. And that might be an underlying principle here at First Resonance, and something I think about a lot is how can we turn a lot of what has been kind of industrialized, ironically in manufacturing, into more creative work.
Yeah.
Right. How do we turn people in manufacturing, which has been a very like process driven workflow, into something that's more artful?
Right.
Right. So
yeah. Because that's where the magic lies. I mean, that's where we get the big ideas that change the world.
Absolutely.
Yeah.
Absolutely.
Well, the other thing that I like about it is meeting your team and knowing your team. And I know all of our listeners, watchers, or whatever, are just getting to know your team.
Yeah.
But everybody is passionate about what they're working on. And you are actually allowing all of these big thinkers in different industries to spend less time on the paperwork, if you will.
Absolutely.
And focus on what they're passionate about as well. Right. So there's a human aspect to it. Right?
Absolutely.
You don't become an engineer or whatever so that you can sit there and like check things off on a physical piece of paper.
Absolutely.
Make sure your parts are in line.
Right. Absolutely. And I think that's especially true in this day and age where industries like energy, housing, aerial transport, space exploration, et cetera, have, again, the systems are big, the outcomes are big, but the work it can be very repetitive. And now as the world, steps forward in terms of like all of the dynamic technology applications that are out there, smart people have choices on what to work on.
Right.
And what we see is a lot of people want to work on fast moving, groundbreaking applications, right? And it should be the case that the physical world is a medium for that kind of fast, innovative work.
Right.
Right. Rather than slow, repetitive work.
Right.
And if we could create that future, I think we solve a lot of problems in the world around us.
Yeah. Well, and so the space industry is probably the closest.
Yeah.
Right. I mean, if you think about the last 10 years, right? Last 20 years.
Yeah.
And I know you come from space.
Yeah,
right.
That's
well,
right.
Not from space, but
maybe.
Well, who knows?
You're right.
But so tell me, like, what could every industry learn from space? Like, what if you could plant one nugget of inspiration in the minds of all of these other industry leaders? Like, what would it be? Like, how could we learn from that growth?
Yeah. I think it's a great question because it ties together some of the points that we just discussed, which is space. And take, for example, something like space launch, right? Rockets.
Right.
Big systems, really cool. The outcome is amazing to see. I mean, what's more exciting than a rocket and all the engines, firing up, getting off the launch pad and, blazing at thousands of miles per hour up into orbit. It's a spectacle. It's exciting. It's amazing. And I think up until just recently, so up until, the early 2010s when SpaceX started on really accelerating a lot of this. And, it's amazing. I had the opportunity to be at SpaceX in those early 2010s.
Crazy.
A lot has changed just in the last 15 years.
Right.
And one, of course, what's changed is the rate of space launches and the payload capacity that has been launched to space, but also the perception.
Right.
Of everyone in the world on what's possible. I think space launch is a really great example where we could see that the perception that we had as a society, as a civilization, space is hard. It's very manual. It is slow. We only get a few launches. Only these, few large national agencies can even do it.
Right.
Has all been questioned and then quickly advanced into we could be fast. We could be innovative. We could constantly innovate. We could create new approaches to all this. We could reuse things that we thought were physically impossible to reuse. So I think the important thing here is just that 4-minute mile story of and I'll come back to that. This breaking the perception barrier, even within our own civilization of what's possible. Right. SpaceX did that with space launch. And what's really exciting to me is we are going to see in the next 5-10 years, if not quicker, these perception boundaries being broken in energy, in housing, and in many other industries. If we're not already seeing them, I think we're living in that time.
We're a little bit.
Absolutely.
Yeah. We're starting to get there.
Yeah. That's right.
So if you had, just before we move away from space, who has you excited within the space industry in general? Like, who's doing new things, just so we know who your babies are there.
Yeah. So okay, I'll answer your question with like a really good, like kind of like meta topic that is being talked about more and more. Interestingly enough, there's an entire and growing group of people who are looking at space as a function of the payload capacity and the actual payload dimensions of Starship.
Okay.
And that's very exciting to me. I'll tell you why.
Okay.
It wasn't the case historically that the way that we ship material around the world was standardized. It was the advent of the standard shipping container,
of course,
that standardized, shipping, of course, logistics, and then logistics and everything in the world around us. Only after that was standardized, right?
Yeah.
The fact that people are thinking about space as a function of the payload capacity of Starship gives me kind of like a sign of that standardization of what the entire logistics network of humanity's relationship to space is going to be.
Yeah.
If the shipping container is a good analog for the development and progression of global logistics, it is to Starship to galactic logistics.
Right, of course. Yeah.
That's very exciting. So the fact that conversation is being had, that we're moving beyond just like bespoke payload development and bespoke payload delivery into standardizing around the Starship payload capacity. I think people who have that perception and are developing around it have an outsized competitive advantage because they see where the world is going around the standardization of this.
Yep.
But two, the fact that we're even having this conversation means that like all of this is moving way quicker than the development of global logistics, which is incredibly mind-blowing if you think about.
That is mind-blowing.
What space could look like in 20 years, right?
Yeah, of course.
It's incredible.
Of course. Yeah. Cool. Well, thank you for that.
Yeah.
I just had to pick your brain on that one since you are one of the experts.
Yeah.
So if you think about who you're worried about, or what industries you're worried about. Like we talked about who had your positive attention, who had you excited. Who has you worried? What has you worried right now?
Yeah.
What needs disrupted?
There's a lot to worry about. And I'm an optimist, so I get worried about worry.
Yes. Yeah.
But at the same time, I think especially in hardware manufacturing and the worlds that we live in, these are industries that are deeply entrenched, more so than I had even really realized.
Yeah.
And what's really got me worried is, a few years ago, I used to kind of think in my mind, like, it's either I'm crazy or they're crazy.
Okay, I've thought that a couple times, but I don't know.
Yeah. when I say they, I'm talking about a lot of these, organizations and institutions that have been around for nearly a century, at least many, many decades. And the way that they've done it is like tried and true, and the systems that they build are big. So it's either I'm crazy or they're crazy.
Right.
Recent events, I think especially in aviation and commercial aviation, which is very like close to all of us, is, this isn't the far out stuff. This isn't just, a one-off accident in some, really kind of like scientifically categorized industry like space exploration or even nuclear power or something like that, which can be quite catastrophic. This is stuff that like is touching our daily lives.
Right.
You could see that the seams are cracking.
Yes.
And that has me very worried.
Yeah.
I think, the proof and the observation is there from industries that precede, like big aerospace, for example. We've seen this in like big telecom or big compute, of like very large companies not being able to actually sustain, of course, their own operation, but also the industry as a whole.
Yeah.
Industries do evolve. And I have this kind of meta thesis of the eventual kind of modularization of every industry. and more democratization of the participants in that industry. We're seeing that in things like commercial aviation. Of course, we're definitely been seeing that in a very positive way in kind of dual use space industry, right? Like so. That's a good thing, but what's really got me worried is these really large institutions that we rely on for daily activities like vacations and logistics and transportation overall, and the seams cracking there, right? So, and I think the way that we solve those problems, I don't think that the solution is in going back to what used to work.
Okay.
And I think that's going to be a challenge for a lot of these institutions. I don't think something went wrong.
Yeah.
I think what's happened is that these operations have not kept up with how the society around them is changing, and the expectations for the workforce and how that all works. And if we just go back to the tried and true, we're actually only going to, kind of double down on the risks associated.
Because we need a solution that serves society and the expectations of the users of this technology, right? The passengers on the plane, the people who are actually, flying, without a thought in the world, right? You don't even think anything before hopping on a flight anymore.
Absolutely, right? So we really, this is like, and interestingly enough, commercial aviation is one of the safest forms of transportation right now, which is amazing.
Yes,
it's and that's still the case,
right?
That being said, how do we ensure that continues to be the case?
Yes.
The passengers on the plane are one part of the system. The people who are building it in the factory, they're living in a whole different world. So one thing, one fun thing I think about a lot is the technicians that are coming into these factories, compared to 20 years ago, they're leaving the factories and they're scrolling Instagram or TikTok or, and these are actual psychological shifts in how these people, these humans interact in the world around them, how they communicate with their loved ones, how they exchange information.
Of course.
But the systems that they come into to work with every single day that they're working, which is a big part of their lives, many of these systems have not changed. So something is not kept up.
Interesting. So is the UX within the systems that they're working with every day meeting the expectation that they now have as a member of modern society?
Exactly.
Right.
Exactly right. Yeah. And clearly not. Right? Clearly not. But these are the second, third, maybe fourth degree kind of things that I think if we don't really peel back the onion and take a serious look at and invest in their advancement, these problems will continue to happen right under our noses, right? The systems that we use to do the work, to build the things every single day, it's the systems that need to evolve, and the psychology and all that. As opposed to just the outcome. We don't need a big hammer to fix the problem. We just need sharper tools.
Right, absolutely. Because the demand and the expectation is increasing. So we need to make it easier on those whose responsibility it is to execute these tasks. Right. Let's make it as easy on them as possible.
That's right. And look, the opportunity is massive to those organizations who embrace that, because the opportunities that come out of just the huge tectonic shifts in the cost of storage and the cost of compute are massive. So it's a really big opportunity. It's not, it's not only something, the cost of storage and compute going down this much isn't just something that's like, hey, let's go tack this on. It's just a big opportunity. How do we rethink how a factory works entirely and how the people work within it? And I think realizing that opportunity can lead to massive, massive outcomes for these organizations, right? It's just, it's free time, money, quality that's sitting right there, because the cost has changed so much from when these companies first started, their digital wave. So industry 3.0, you could call it, into what we have now, which is evolving just at it has been evolving. Crazy. Yeah, absolutely. Yeah.
I want to talk a little bit. I want to get into this data a little bit, but I want to bring it into full view with another concept.
Okay.
And this is something that I have learned since meeting you. So thank you for that.
Okay.
The amount of data first generated during manufacturing in any industry, right? The amount of data, and a lot of that data is just wasted.
Yeah.
And it could be used for so many other things.
Right.
So I want to ask you, why is this data being wasted? You know, what could it be doing? What should we be thinking about there?
You know, I think it's a really interesting question because no one set out to waste data, or nor were these systems set up to necessarily throw this data away per se. It's just the way that these systems were designed. They were designed around the constraints of how expensive keeping all data and then constantly computing data used to be 20, 30 years ago. A lot of that has changed. So, but what does that mean? Why is data being wasted? Well, effectively, it's the same reason that we compress data overall. There's so much that happens in the world around us all the time. There's certain things like that we need to do to help inform one another in a concise way, in a way that makes sense. So, like, abstracts and summaries, right?
Right, of course.
Effectively, this is what factories run on. They run on this concept of, okay, a large process happens. And the most interesting thing about hardware and manufacturing, I think, is that they generate a very rich amount of data. The data is very rich, it's very dense, but it was impractical to store all of that data because it was just very expensive. And anyways, in order to move one part down the line, you didn't need all that data. Right. So what typically happens in manufacturing is you run a process, it generates a whole bunch of data, and then it has some sort of outcome, like a pass or a fail. Right. And then in order to keep that piece of hardware moving along the line, you save that important piece of outcome, pass or fail.
Right.
And then you advance the thing down the line. Now, historically, it was only practical to store pass or fail.
Right.
And then you either keep the rich, dense data on a local drive and never upload it, or you just throw it away entirely because...
I've heard there are file cabinets.
Oh, absolutely. And yeah, exactly. File cabinet. I mean, we're going way back with that. File cabinets.
There's no fire.
Exactly. Right. And, so storing the data in file cabinets, if you even do that, but typically, just keeping it at the local line, keeping it on a local hard drive is just impractical to send all this data.
Yeah, of course. Because you have to pay to store it.
You have to pay to store it. Right. Storage was expensive. I mean, I think everybody remembers, flash drives. Remember a terabyte flash drive? First of all, that was like gold. It was like, I don't know, like, $500 to have a terabyte thumb drive back in the day.
Of course.
Now these are like
$20. Those were the cool people in college. Yeah. Wow, that guy's...
Yeah, exactly. Right. Wow, that's a terabyte, right? That's pretty incredible. And now, it's $20 a pop. If even that, even my information might be outdated. So the cost of storage has gone down a lot, which means, again, it just, the opportunity is massive to store more data. Right. Interesting thing is, as manufacturers have come to this realization over the last 5 to 10 years, like storing the data is step one. One of the things in manufacturing as well is manufacturing is one of the largest producers of data in industry, and even storage of that data. The problem is access. So getting into one shared area on a network that everyone can access. And then, of course, making continuous use of that data is the next opportunity frontier.
Right.
How do you correlate disparate information throughout a factory to find kind of anomalies or, interesting behavior that you wouldn't have otherwise been able to find at all without intensive effort of like stitching together patches of data, right? And I think when we were talking earlier about what can the brain power of people working on the very repetitive work go toward, it could go towards this. It could go towards interacting with a proactive system that says, hey, I found this thing. I'm just a computer.
Right.
You might want to take a look at this. And then that's where real human brain power could come in and say, great, I got this insight. I got this behavior. And now I can apply my brain power to making sense of it and getting even more proactive and making suggestions and design improvements in line at a faster rate, and improve outcomes like to a scale and level that, I think we're only just starting to see what's possible. If you look at companies like SpaceX and Tesla, and their ability to rapidly innovate and iterate. It's not just their will to rapidly iterate and innovate, it's their use of these types of systems and data that allow them to do that, right? And they've changed the way that people work inside of those operations to relate to this data more, right?
Right. So they started with the mindset.
It's a mindset,
right?
thing.
Of we are going to embrace iteration.
Right.
And then they figured out what systems they needed in order to support that mindset. Because you can have the mindset, and if you don't have the support, well, great. That's a great theory.
Yeah, that's right. That's exactly right.
Where we can come up and support that effort, right? And even encourage it, or not force it, but what would be the word?
Well, I think, if you have the mindset and then you codify that in your systems, and then the systems reflect back into the mindset, really what you're doing is influencing the culture.
Right.
So at that point, you don't have to force it.
Interesting.
Right? Because you've created a culture of, what does a data-driven, systems proactive manufacturing operation look like? Yeah. And then what does it feel like? And then what does it feel like to be in that? You start looking to solve questions around production capacity or quality management in a whole different way. You start to look at quality management as something that's more of a data science problem rather than a paperwork problem. Yes. Right? Yes. And that gets really, really interesting. So it's really, I think, a culture thing.
Yeah. You're making it cool like the terabyte flash drive in the early 2000s.
Yeah. That's right.
All right. Let's pivot a little bit.
Okay.
I want to talk about quality. Quality.
Great.
So as we're manufacturing anything, especially a complicated machine or something that's more complex, the traditional way, as I understand it, and again, this is from a layperson, is that quality was typically assessed at the end of the manufacturing process or pretty close to the end. So how is that changing? How should we be thinking about quality? Like, what do you see?
Yeah. So you're right. And this is very much the case in many applications today where quality checks are done at the very end. I think a few examples of this, major large-scale telescope projects as of late had like these issues at the very tail end of the program. After, over a decade and after billions of dollars of taxpayer dollars, just these like, critical tests that ended up resulting in these fasteners popping off of the telescope in the final stage of the test. We just saw this very recently. So this is very much how like large scale like projects and programs are working today. You do all of your checks on the back end.
Okay.
That is changing. I think what we're seeing is a lot of the principles that we've seen from software, such as unit testing. So testing small pieces of code in discrete elements very regularly, very often.
Little batches,
just like the most. So unit tests themselves, like if you think about just units of work, how do you test smaller and smaller blocks of functionality? We're seeing those concepts now come out into the physical world and hardware. So at SpaceX, for example, we talked a lot about these principles of shifting testing left. So rather than waiting to do all the testing during the hot fire or even like, individual engine tests, like we brought up as much testing at the, even the level of like an individual resistor.
So each individual component is tested multiple times by the time they come together.
That's right.
The idea is that each one is as perfect as it could be.
Yeah. That's right. And you're removing error up front from the entire system. And so specifically what I mean by that is you could think of a rocket as one piece of hardware. Right. But the reality is it's actually tens of thousands of unique parts that need to come together in the right way to result in that one rocket. Right. Now, the interesting thing about rockets in particular is that all it takes is one part. Now, this is barring things like redundancy architectures and whatnot. Right. But in certain cases, in fact, it is the case that it just takes one part for all 10,000 to be meaningless. Right. And so how do you mitigate that? You find that one part and you segregate it out of the system and you do it as early as possible, reduce your costs.
Right. So now we're talking about time wastage a little bit because as I'm envisioning this, you get to the end and maybe this is like my blown out vision of this, right? A little bit comical, but you get to the end and you're like, oh, wow, we have this massive, very complicated and expensive thing.
Yeah.
It's not working.
Right.
And we have to go back to the very beginning and figure out why.
Right.
So we're not only eliminating, waste of data, now we're eliminating waste of time because you are segregating that thing all along and you know which piece isn't working.
Right. Exactly right. So one of these other software principles, so we talked about unit testing. So testing smaller and smaller parts of a full system and identifying where you need to fix the problem. One of the metrics that software engineers use to think about the health of their software quality program is this concept of mean time to resolution.
Okay.
And specifically around that, it's like, while software is inherently going to have bugs every once in a while, how quickly can you identify that bug and how quickly can you resolve it? And at what stage can you resolve it? Ideally, you can resolve it in unit testing. So before it even goes into the master branch, and then, if not caught there, you can catch it during a release branch or a staging phase before it goes out into production. And then of course, if something slips into production, how quickly can you recover and have redundancy in the system to make sure that the entire system doesn't collapse? These are software principles of creating resilient architectures and great functionality for global scale software systems.
Right.
Hardware is starting to embrace these principles. It's hard. It's hard, however, because bits and bytes are much faster and cheaper to move than atoms. But by baking in these principles into the atoms world and shifting testing left, doing testing early, doing it often, doing it in a more modular way, you can find these problems and root them out earlier. So it's more upfront work and thought around quality. Yeah. But what you end up getting is a lot more reliability in your end outcome. And consistency.
I mean, when I'm thinking about this, I'm thinking about some of the big disasters throughout history and how maybe they could have been avoided if there were quality checks in an iterative fashion, the way that you're talking about.
I'll give a very specific example. The Challenger incident is one that's pretty sensitive and one that is unbelievably sad, really. That O-ring on that side booster failed because of the temperature conditions of the day of the launch.
Right.
And how did that O-ring get there? How was it that shuttle was cleared for launch? Well, it was because basically there was testing done, but all of that information was compressed and it was just stage gates, passes or fails all along the way.
Gotcha.
And if everything just bubbles up to a pass and you get to the end, it's basically just decision making on a few data points that are aggregate as opposed to decision making on a large set of data that allows you to make use of the fact that the temperature conditions here are outside of the boundaries of anything that we've tested or qualified to. But if you do that, you could avoid these huge errors.
Yeah. So if that O-ring was tested at this temperature, and at this condition, and that condition, iteratively before it ever came together, with the rest of the system,
correct. Yeah.
That tiny thing that causes massive disaster could have been avoided.
Yeah, we could have just made a better decision. Yeah. Absolutely.
Wow, crazy. That's profound. If you could give this iterative testing, if you could say, okay, this is I'm going to ask you for your favorite again.
Yeah.
This is the industry that I would say, okay, let's transform it first with iterative testing again. Which would that be and why?
Yeah. I would say space launch systems, so rockets, but that one's too easy. And I think SpaceX has nailed it. One area where I'm really excited about, with this approach is, again, coming back to nuclear power.
Yeah.
The reason why we know that these nuclear power plants are extremely complex. They're very sensitive. There's a lot of moving pieces. It's basically as complex as a rocket, if not more, on the ground with a lot more implications if something goes wrong.
Yes.
Testing the various, kind of sub-assemblies and modular parts of a reactor design in this way that we're describing here, rooting out more of the possible issues and building redundancy into the system through rapid and iterative testing, I think changes the game to the point where you can employ these things and actually make it a part of the kind of safety, quality, and regulatory process It's an area that I think is going to rapidly evolve in the next 10 years. But specifically what I'm getting at is like, not only are you assuring the operational excellence at the quality level for a reactor,
right,
but also the quality outcome, and then also starting to influence how we regulate something as complex as a nuclear reactor.
Yeah. Well, and the thing that this brings to mind for me is all of the bad press of nuclear energy. You know, all of the past beliefs in nuclear energy and the dangers therein. If you can prove the regulation,
exactly.
This is the transparency. This is exactly how we're regulating it now.
Exactly.
How we're testing it now.
Exactly.
Then that starts to dispel some of that hesitancy.
Yep.
Right?
Yep.
And then once the public wants it, the country is going to invest in it.
Exactly.
Right?
The country's going to invest in it. I mean, if we think about how this really expands out, like into maybe even commercial and daily practical applications, like every family has a reactor.
Yeah.
Like a microreactor in their home.
Wow.
You know, would the general user or consumer today, and I call it a consumer because I am saying that it could go into a consumer application.
Right.
Would they feel safe with that today? Well, you know, a lot of this like perception baggage that we have from before precludes that. Right. But if we could show through like science and these rapid iteration testing principles that these are safe, individual homeowners would happily put a nuclear reactor in their home and power their home for 3 years until they need to swap out the core, right?
Right, without worrying.
Yeah, without worrying.
And they'll have children and everything else and not worry about anything going wrong. Yeah. Well, and the other thing that I hear about with nuclear energy, right, just having conversations with people who have opinions about it in the world, is the cost. Right?
Yeah.
So if we've got quality checks in manufacturing, if we've got these systems that are making it easier, right, and safer to manufacture, how does that affect the cost, right? If we look at the cost of a country investing in it on a national scale, or the cost of even going to consumer, I mean, that unlocks the consumer possibility because it reduced the costs, or...
I think that's absolutely right. I think like, you know, these principles, again, the more you modularize, the more you kind of rapidly execute cycles of testing and safety and quality, and you have a better mean time to resolution, like we were talking about earlier, you're basically just removing all of the overhead that you would have had to tack onto the back end to ensure safety and quality. You're just baking that into the system. Right. And you're allowing for more rapid iteration into that entire system design. Yeah. Right. The sooner you can find problems. I mean, this is kind of the simplification of this idea. The sooner you can find problems, the sooner you can fix them. Right. And the smaller the problems are, the smaller the cost to fix them. Right. So you might as well do both of those. Right. You know, let's just choose that. Exactly. Rather than wait for bigger problems with bigger costs to fix. Right. Just do the smaller things and chip away at it. And that impact, it's this concept of like garbage in, garbage out. Yeah. The less garbage you have in throughout the entire system, the less garbage you will have out. Right. It's kind of like going for a run every day instead of needing to, at the end of, you know, when you're older, like have some sort of valve replacement. Well, you could go for a run every day. That's right. And improve your heart health iteratively over your lifetime. All right. So let's get into one more type of waste. Okay. I know this is on everyone's minds, but I have heard that manufacturing creates a lot of physical waste, and there are ways to eliminate that. Yeah. So tell me about it. So manufacturing creates the world around us, right? Everything here, the chairs we're sitting on, the camera that this is being recorded on, devices that, you know, our audience is watching this on has been manufactured. And so for that reason, obviously manufacturing is a large industry. A lot of material goes into manufacturing and a lot of it is wasted. 90% of the material that goes into manufacturing is actually wasted. Wow. And 30% of the material in landfills actually comes from manufacturing. Yeah. These are big processes. Manufacturing, a lot of, you know, chemical and material transformation, which also means that manufacturing is the third largest contributor of climate emissions. It's pretty big. These are big systems transforming a lot of material to build the world around us, and it could be quite wasteful. mitigating that and fixing that, or even making a % improvement has a pretty massive implication on the waste in the world around us.
Right.
Yeah.
Especially as populations grow and we're making more physical things.
Right. Right. Absolutely. Right. Absolutely. Populations grow. We're making more physical things. The standard of living is increasing as a function of this. You can't have, a civilization that has better outcomes for well-being if they don't have the materials that define well-being.
Of course.
Food, water, shelter. A lot of those things are manufactured.
Right. Of course.
In an interesting way.
So, yeah. So in the future, we could be wasting less time during the manufacturing process, less data, making it work for us more, and also less physical items.
Yeah, I think that's right. So, breaking that down and the way that we think about it, the physical items is definitely the most, obvious in that list, right? Less physical waste means less, material in landfills, and just overall less waste of cost too, right? Why throw away the material? And so how do you reduce material waste is something that we think about a lot here. And there are a few different ways to do it very much on the surface level, but one outsized way to do this is waste less information. A lot of the material going into factories is wasted because it's either over ordered or underutilized.
Okay.
Right. So you might think about, kind of a block of metal that was purchased by a factory in order to machine it to have some sort of outcome. The rest of that material is just scrapped.
Right.
Because somebody bought a unit of one that serves this unit of one for the item being sold, and then the rest is just waste. But that might not necessarily be the case. It might actually be that this block of metal for another part number from a different department altogether can actually be used for its application. So you don't have to throw that out. A lot of factories work in the former way with more information applied to this and connecting this disparate information.
Right.
We believe that you can actually waste less material by making more of that information reused within the factory and within individual decision making. Right. One fun example that I think about is in manufacturing in particular, there's these minimum quantities that need to be purchased of a certain material, especially at the industrial level. So let's simplify the example. You could think of something like a valve. Let's say I'm an engineer that needs 5 valves for my product. You're an engineer that needs 5 for yours, and then we have 3 peers that need 5 for theirs. But the minimum order quantity is 10, or something. Let's say it's 10. We actually just need 5 orders of the said material or so. But we might actually, as a company, just over order by a factor of 200%.
Right.
And then what do we do with the rest of the material? Well, in many cases, these material expire, so we have to throw them out. This is why we have so much waste in manufacturing, is that it's a lot of blunt decision making without really pulling together all the information and all the requirements and how we can make the material most useful. Right. So I think there are very simple ways to do this.
Right. And you're breaking down silos as well. Like everybody's worried about their own project.
Exactly right.
And then you're like, well, did you know that you could actually have this piece that you're looking for right now?
Exactly. Right.
Yeah, that's great.
Exactly right. Yeah. So that's one way to reduce waste. There's another one, we were talking about time. How do you reduce the waste in time? And by the way, why is time so useful in manufacturing? Well, every second that's wasted, that means that there's a machine on, the lights are on, the factory is operating. There is a fixed overhead where this factory is, consuming large amounts of energy. And so every second wasted is waste. The more time you can save for decision making and information transfer, the more performant the factory actually is, the more production is actually going on, the more utilization of the factory itself. In fact, manufacturing has always tracked this major metric, OEE, or overall equipment efficiency.
Okay.
And the utilization of a machine is a key indicator of a factory's performance and health. The more we can bring that up with less, kind of time wasted between runs or in decision making or part shortages, the more uptime in a factory we have, the more production we have, the less overhead that a factory is just burning energy into the air, right?
Right. We don't want to leave all the windows open and the air conditioner on.
That's right. Yeah, that's right. That's exactly, And factories are doing exactly that in many cases. Yeah,
right. Yeah, so we're actually improving the green aspect of the factory just by eliminating this waste.
Correct. The good news is a lot of the principles that manufacturers have always cared about when it comes to the health metrics of their business, things like OEE or factory throughput or even quality or like reducing rework, right? And recalls are very aligned with improving outcomes for energy problems.
Right.
The more performant a factory is, and again, remember, manufacturing is the third largest contributor of climate emissions.
Yeah.
The more you align factory outcomes with everything that they're doing, the better the climate and energy outcomes too.
Right.
And that's pretty amazing. That's a really big opportunity, right? Green factories are good for the business, are good for factories, and they're good for the environment.
Right. And that's an interesting thing, right? Because certain factions really care about the green factor. Mm-hmm. They really care about being a green factory, being a more conscious factory. But even the ones that don't, right? Or in parts of the world where that isn't emphasized.
Yes.
If it just makes good business sense.
Exactly.
Then you're changing the world for the better.
Exactly.
Regardless of the intention.
Exactly right. That's the best piece of that's what makes me very hopeful and optimistic is that these things are very aligned.
Yeah.
So you're right. A small faction cares about the green factory movement, but everyone cares about
business outcomes. Yeah.
Right?
Well, cheers to that.
Cheers to that. Yeah.
We've solved it. He solved it. This guy solved it. So I want to ask you one last question before we let you go.
Okay.
Give us one more thing that has you excited to be alive right now. What are you excited about?
I often think about, probably more than I should, but I often think about just how amazing it is and how much the world has changed in the last century.
Yeah.
I think there's a lot of pessimism out there about the state of the world and the problems that we have. But if we really compare it to the global state of like the human condition, so looking across the whole world, comparing 2024 to 1924, let alone 1824.
Right.
I mean, it is absolutely night and day. I think it's a miracle.
Right.
I think it's a miracle that we're having some of the conversations around quality and equity of humanity, just in itself, that people globally have access to, things that, again, are magic and miracles, like internet from space and satellites, like having that connectivity to build small businesses on the internet and in the world around them, in places in the world that a century ago were honestly so oppressed. To me, it's magical. It's miraculous. And I think it's something that I feel truly grateful to be alive for during this time. Right.
Yeah.
So, and that makes me very hopeful for the future, right? I can only imagine what it looks like 100 years from now.
I agree.
Yeah.
Well, thank you so much for your time.
Amazing.
I appreciate it.
Yeah.
Thanks
Cheers.
for all the inspo. I hope you guys have enjoyed as much as I have. We will be bringing these insights from the CEO of First Residence out on a regular basis. So join us next time.